I had dinner with my family, so it was great.
Yay! At least you had dinner with
Yeah.
everyone.
Well, I got off work at like 3, so it was
Oh,
like
sweet.
nobody does anything before 3 on Thanksgiving anyway, so it was fine.
Nice. That works out perfectly then.
Yeah. I was a little mad that we had a test that week too. I was like, come on, guys, give me a break.
I know. My chemistry class put off the test for this week.
See, that's what they should do. I guess it's nice though, because now you don't have to take both on the same week.
It is nice instead of scramming for that.
Okay, so what did you put for number 1?
Okay, so for number one, as heat is transferring from the hot liquid to the alcohol, the heat first reaches the glass of the thermometer, causing it to expand, which makes the inner volume of the thermometer increase, while the amount in the glass tube is constant. Once the heat reaches the alcohol expands. Thus, at first it falls, then rises.
That's what I have. Yeah.
Yay.
Yeah, just different words. Okay, for number 2, I use the equation. Where my dog is barking. Delta L equals alpha L delta T. And so I ended up doing delta L equals 12 times 10 to the negative 16 multiplied by 10 multiplied by 35. And that gave me 4.2 times 10 to the negative third meters.
Okay.
Is that what you got?
Um, how did you get 12? Just wondering. Because I
Um,
got 11.
Let me go back and find my sheet. It's somewhere in here.
Because they're both roughly about 4 millimeters.
Let me go find it. I'm going to tell my dog to be quiet.
Okay.
Okay, give me 1 second to find it.
Okay.
This was one where I just looked up a table to find it. Did you just get yours from a table? Because I just looked
Yeah.
at thermal expansion, but I didn't use the textbook. Did you use the textbook?
No.
Okay, great. Okay, so 13 said 11. Let me look up a different one.
Well, I just looked one up online and it says it's 13 instead of 11 or 12.
Okay, cool. That's not helpful at all.
That's at 20 degrees Celsius.
Oh, I think that's what I did wrong. I don't think I really looked at the temperature. Like, I think I just kind of like looked and, you know what I mean? Like, I didn't take the time. So, what was it supposed to be? 11?
Well, I have 11,
Oh,
but
but
even with your 12, it's still about 4 millimeters.
okay.
Because mine comes out as 3.85 to 10 to the negative 3
Yours is
meters.
4.85 or 3.5?
3 point.
Oh,
Sorry if I said 4.
no, it's okay. Um, but yeah, I don't even know how. Let me look.
Is there something in the book?
I thought there was. I think it's like in the very back or something. Maybe I didn't get it in the book. I remember going to the back of the book for something.
Let's see. Week 11, temperature and expansion.
Oh no, it wasn't in the book. It was in some like textbook that I pulled up online.
Oh,
It has like the same little books, as like ours when you pull it up online. So I figured it was the same.
which makes sense.
Yeah.
And I can understand where they're getting all these different like 11 through 13
Mm-hmm.
because depending on what type of steel you have, it has a different expansion rate.
Yeah. So what do you want to do with this one?
Um, where is it?
Where's page 512?
Here we go. We might find it here. So yours is right. 12. I found the table.
Okay. Where was
So
it? Where is the table that you're looking at?
so I had to go to the web
Mm-hmm.
one, and it's underneath 13.2, but I had to go find it.
Okay.
So I clicked on the first link that says thermal and expansion, and I had to click about 4 or 5 times to find it.
Okay.
But yours is right according to the table I have for iron or steel.
Okay. All right. Well, we can use mine for that because they're barely off, right? Okay. Yeah, I'm seeing it now.
Yeah.
Oh no, this is the same one I looked at earlier. Maybe I have it open in a different page. I don't know. Yeah. Okay. 12 times 10 to the negative 6. That's what I put.
Yeah. So yours is right. I understand where they're getting all the different numbers from where we're looking,
Yeah.
but I'm guessing we're supposed to use this one though.
Yeah. All right. We can use mine for that one. So that's totally fine.
Okay.
All right. How did you do number 3?
So number 3, I used the equation PV equals NKBT,
Yeah.
which is really close to PV equals nRT, but
Mhm.
with a different constant.
Yeah.
And so I rearranged it so because we're looking for how many atoms there are.
Yeah.
So small n equals capital N over V, which equals the P over the KBT.
Yeah.
And since we have the P over the KBT, um, we can plug that in. So you have the 1 times 10 to the negative 7th
Hmm.
over 1.3 times 10 to the negative 23rd times 293 Kelvin. You can get approximately 2.47 times 10 to the 7th atoms per centimeters cubed.
Wait, say that one more time. How many?
2.47.
Okay, that's the same as what I have. I just did it. I just used the you use that equation a lot in chemistry. In 105, we call it PivNert. So I use PivNert to do that. But yeah, that's the same thing I got.
That's awesome.
Yeah. I saw that and I was like, this will be a good week for me. All right.
No. That's what we're doing in 101 right now in
Yeah, so
chemistry.
you're like, oh, this is great. Let's stay right here for the rest of the semester. All right. So for A, I used the same equation. So I divided the nRT by the V to isolate P. And so I did 3.6 multiplied by 8.314 multiplied by 273.15 minus 25 divided by 30 times 10 to the negative 3, which gave me 297, yeah, kilopascals or whatever. Yeah, kilopascals. And then for B, I have like the N total equals N1 plus N2, or like the prime if you want to do the prime. And
Okay.
so for, I have 101.26 divided by the 8.314 multiplied by let me read my handwriting, 273.15 plus 25, which gave me 0.04. So then the final n is the 3.6 plus the 0.04, which gave me 3.64. And then to get P2, I have P2, and then I set it up so it's P1 N2 divided by N1. So I did 297.3 multiplied by 3.64, which was that N we just solved for. And then I divided it by the 3.60, which we were given in the problem. And then I got 301 kilopascals.
Okay. So I did mine in atmosphere because I wasn't sure which one
Yeah.
was supposed to be. And according to the conversion, it's about the same
Okay.
since one ATM equals about 1.07
Mm-hmm.
Pascal. So it equals about the same. I just have 2.93 ATM on the first one and a 2.03 ATM on the other. So when it converts, though,
Yeah, that makes sense to me.
yeah, I just didn't know which one to use because there's so many different.
Wow. Yeah, I know. Because there's like four, because you could also do it in the millimeters of mercury. Like you could do it in whatever you wanted, as long as you did it right.
Right. I just think it's funny. I ran into that problem with Maple TA last week. I'm like, which one is it?
Yeah, Maple TA. So I did all of it, and then there was like two questions where like no matter what I did, I kept getting it wrong. And sorry, there's somebody in my house. I'm in the middle of something. I know, my friend needs to see. Mom, no, wait.
Just real quick, Poppy, I believe.
Mom, I'm in a meeting right now.
Okay, sorry. Bye. Sorry.
That's my mother. I don't remember what we were talking about now. It's gone.
Something about Maple TA. But.
Oh yeah, so there were like two questions that like I couldn't get him right for the whole week, and I emailed him like 4 times, and finally he was like, "McKenna, you rounded too early," and I was like, "So I did it right the very first time, and I've done it 8,000 different ways since then. Thank you so much."
Wow.
And I was like, "You could have told me that first." Yeah, so that was fun.
I couldn't get the last one. Whatever we did, we just couldn't.
I don't remember what the last one was.
I kind of do, but it just wasn't working out no matter what I did.
I think it was like number 1 and number 7 that I had problems with. All right. How did you do number 5?
So number 5, I used the equation. My brain did. VRMS equals V squared square rooted, which equals the square root of 3kt over m.
That's what I used as well.
Rearranged it to get t by itself. And
which is mv squared divided by 3k, right? Or 3n.
Yeah, mv squared divided by 3k. And then I plugged in the numbers of. Dang, I almost couldn't read my hand right there for a second. So the hydrogen of 3.349 times 10 to the negative 27.
Okay.
Times that by 193 squared.
Yeah.
Over 3 times 1.38 by 10 to the negative 23rd.
That's what I did exactly.
And I got 3.01K.
Yeah, that's what I got.
Okay. I always wonder if I'm using the right equation because some of them just get really funky with different letters.
Oh, yeah, and I agree. Because there's like the same letters in every single equation, but they're not always the same, and it doesn't always solve for the right thing. It's a pain.
Yeah.
All right, for number 6, I said the 3 things that affect heat transfer or to change an object's temperature is the degree of difference between the temperatures of the objects.
Okay.
And then the mass and then the specific heat of the object. So the mass of the object and the specific heat of the object.
Okay. I said change of temperature,
Yeah.
mass of the system, the substance, and the phase of the substance.
Is it mass of the whole system or just the object?
Well, it can be the mass of the whole system because say you have a 3 kilogram weight that you've heated up, but then you have a 2 kilogram thing of water.
Yeah,
They'll vary between a 4 kilogram.
Yeah, whereas if you threw like a 3 kilogram weight thrown into the ocean, it doesn't matter. Okay, that makes sense.
Right.
I'm following
Yeah.
now. Okay.
Yeah.
All right. For number 7, I said since there's no heat entering or leaving the system, the energy that you need to change the phases, so to melt the ice or turn the ice into the water, isn't there, so they'll remain the same.
Yep.
Okay, perfect. All right, how did you do number 8? Because number 8 I didn't do, but I did number 9. But number 8, I was like, that's a lot of little numbers, and I just...
Well, it ended up being really simple. I just didn't use my space wisely.
Oh, okay.
Yeah. So,
I started writing it out, and then I was like, no, this is taking up too much room, and then I just went to 9 because it had a lot of room at the bottom.
That's perfectly fine. So for A, you use the equation Q equals MC delta T,
Okay.
or change of temperature.
Yeah.
And so you're going to use it a couple times because you have the water and you have the block of ice.
Yeah.
So if I remember, yes. So the block of ice ended up being 3.762 times 10 to the 4th joules once you plugged everything in.
Yeah.
And then the water ended up being 837.2 joules.
Yeah. That makes sense to me.
And then you plug it into the equation to find the final temperature, which will be the mass of water times the specific heat of water times 20. Did I just have a 20? Times 20 plus L minus the mass of the ice, the specific heat of ice. 20 is the temperature, sorry. So the specific heat of water times the temperature plus the amount, L, minus the mass of ice, the specific heat of ice times its temperature, all over the mass of water, the mass of ice, times the constant specific heat of ice.
Yeah, that makes sense.
So then you throw all those fancy numbers in there.
Sure.
And you come out with a final temperature of negative 13.2 degrees Celsius.
All right, I believe you. I'll have to look at that one again. But that makes sense to me. I mean, well, your process makes sense. I'm not sure if the number makes sense, but what you described made sense to me.
Yeah.
All right.
It was a fun one with all those numbers, but...
Yeah, that's exactly why I avoided it. I was like, no. Okay, for number 9, I did the Q equals MC delta T again. So it ended up being the, so I made it 1.05 times 10 to the 3rd instead of just putting out the 1050, since I was already dealing with the 2 times 10 to the negative 3.
Okay.
And then I multiplied that by 4186 by 3, and then I got 2,600 or no, 26,372 joules. And then for the rate, I took the Q divided by T. So I divided that number by 60 and I got 440.
I got something different.
All right, what did you get?
So because mass equals density times volume,
Oh, yeah.
I substituted the mass of that equation
Mm-hmm.
for density times volume.
Mm-hmm.
And all of it over T like you did.
Yeah.
But I ended up with 293.
Okay, I looked at a different example that had 293 in it. Well, I don't remember why I went with this. Let me go try to see the examples that I found and see if I can see what I did different.
That's fine. I'm going to make sure the math is correct.
Well, I remember seeing 273 because I remember being like, is it 440 or 273? So I think it's right. Because what I did first was 440, and then I saw 270. I think it was on like Yahoo Answers. But then I saw another one that was 440, and I was like, that's the answer I got. So I'm going to go with that one.
That. 2 divided by. Yeah, I got 293 plugging all that in.
Let me try my math one more time.
And if I remember right, the unit's supposed to be W since it's the heat transfer.
Yeah, that's what I thought.
Okay.
Oh, wait. Let me make sure I put this in right.
Those units are really starting to get to me.
I know. There's too many of them, and they're all the same, which is really hard.
I thought W was supposed to be something else.
Well, the last couple of weeks we've done W. It was like the speed, like not the. It was one of the velocities or accelerations. I can't remember which one it was now.
I don't know what to do with this class.
Neither do I. Yeah, because I just put in my numbers again, and I got 439.5. But when I'm looking at the other examples where it has 279, or let me go pull it back up so I can see exactly where I did it.
What numbers are you using again?
So I'm using, like you, I replaced the M with the density times volume. So for the density, I have 1.05 times 10 to the third multiplied by the 2 liters, which I made 0.002 milliliters. And then I multiplied that by 4186. Where did I get that number again?
That's water.
Yeah, okay, that's what I thought. And then I multiplied that by, oh, you know what? I had the wrong number there. That's supposed to be a 2, not a 3. Let me see if that changes my answer. Yeah, it would help if I checked my numbers first.
Don't worry, we all make that mistake.
293. Hold on. Okay, so you were right. I just put in the wrong number somewhere. I don't know how. 17581.2 divide by 60. All right, I'm on the same page as you now.
Okay. We will make it through this.
Speak for yourself at this point. I'm just trying to. Well, I guess I have a good grade in this class right now, but I'm ready to be done with this grade.
I'm surprised I've managed a B in this class.
Yeah. Yeah, I have a B in it right now. I'm kind of close. I lost my A, and then I am kind of close to having an A again. So I'm like, This is familiar stuff, although apparently I don't remember it that well.
I am rooting for you in that A.
Huh?
I am rooting for you in that A.
Thanks. So am I. We'll see that. Okay, so which page would you like to send it? Okay, why don't we have you do the second? You have 2 pages printed off, right?
Yes.
Okay, so why don't you do the second page since you have 8 written out, and I can do the first one.
Okay.
Okay. All right, so email me your second page, and I will get that turned in for us.
Sounds perfect.
All right, I'll see you.